Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous lecture we were discussing the control flow and specifically we were discussing loops. So, let us pick up from where we left in the previous lecture. So, we talked about the for loop and we also talked about certain scenarios where few more keywords like continue to advance to the next iteration or break keyword to exit from the loop. So, those scenarios also we have gone through few of the common scenarios in the previous lecture and we talked about the nested nested loops and how we can whenever this situation demands we can exit out of the loop out of the nested loop and into the outer loop using the break statement. Now, let us move on to the next loop type that is a while loop. So, a while loop is slightly different from for loop. In the sense for loop we do the iterations over a collection over a sequence. So, we typically define our sequence and we run through all the number of iterations that are allowed by that sequence. So, based on that for statement we make our iterations. However, in case of while loop we have a conditional expression. So, till that conditional expression is found to be true, the loop will go on. So, in a sense in our following block that we are executing up after that while conditional expression we would like to also ensure our exiting scenario there itself. So, let us understand the same thing through an example. So, here we have initialized a variable x as 1 1 2 and we have I another variable as 0. So, in the while loop I am using the while keyword first and then the conditional expression for this while loop. So, this is x greater than 0. So, right now the value in the initialized value of x is 1 1 2 and till this value remains greater than 0, this 1 1 2 value remains greater than 0, the following block in the while loop is going to be executed. So, if you look at the following block, the first line itself we have ensured how will exit out of this loop. So, there I have the conditional expression if I greater than 200. So, whenever the value of variable I becomes greater than this value 200 we are using the break statement. So, we will be able to exit out of the loop. So, in the following lines of code I am increasing the value of I plus equal to x and x also I am using this x and this operator double forward slash operator here to continuously decrease the value of x. So, let us run this. So, let me go down here to the while loop block. So, if I run this, let us check the value of x. So, you can see it is 7 and then if I check the value of I, you can see 210. So, of course, that is greater than 200. So, this conditional expression was executed. So, the value of x was still greater than 0. So, as per that while keywords conditional expression, so that was still evaluating to be true, but he had the exit scenario there where if the value of I greater than 200 we had used the break keyword. So, that scenario was achieved and therefore, we exited out of the loop. Now, let us move on to the next construct, that is pass. So, this particular construct is typically about when we do not want, we might have a particular block where based on certain condition we do not want anything to be executed. So, this is mainly coming because we use white spaces in Python. In other programming language we have braces or other things which in a sense allow us to leave those braces without any statement and therefore don't have we can manage when we don't have anything to execute in that particular block of code. However, in case of Python, because we are using white spaces, we need this kind of keyword pass to explicitly tell the interpreter that we would just like to pass from this particular block of code. So, we can understand the same thing through this example. So, the first conditional logic block that we have is if x less than 0. So, value of x is presently 7. So, this will not be true. So, if x less than 0, then print negative action, else if x is equal to 0, then no action now to be coded later. So, if this block is if we do not want any action at all, then this will just work fine. If we have just planned it in a sense that we would like to add the code later on, the whole code is in the development process and we might not have focused on this particular we would not like to focus on, we would not like to code this particular block as of now, then we can use the pass keyword here. So, if this elif condition is met, if it is evaluated to be true, then pass keyword would do the job, and then the next block is else, that is the catch all block that we have. So, if all above conditional expression are evaluated to be false, then this is going to be executed and will print this statement positive action. So, in this case since value of x is 7, which is positive, so we will actually be printing this else block. So, let us run this. As you can see, positive action message is actually printed. Now, let us move to the next thing. So, next we are going to discuss this range function. So, in the previous lecture you might have seen that we had used this particular range function for iterating over a collection, a sequence. So, this sometimes can be really useful. So, let us understand how this particular function works. So, as we did for the for loop before in the previous lecture, this range function is typically used to create an iterator. So, whenever we would like to iterate over a sequence, so this particular function can actually be used to create that sequence. So, typically this function accepts 3 arguments, start, end and step. So, where we would like to indicate which value and how we would like to start, and then the end part of it and how we would like to step. So, so step might also be negative in here. So, after we run this, it will return an iterator that will yield a sequence of evenly spaced integers. So, actually it is going to return us integers and evenly spaced integers. So, let us run this range 5. So, here you can see I have just passed one argument. So, this is one way to call this function. So, you can see range 0 to 5. So, if I just pass this, so the start argument will default to the value 0. So, the iterator would be from 0 to 5, and as we said, it is sequence of evenly spaced integers. So, this range 0 to 5 and step value would be 1. So, it will default to 1 and the range will start from 0. If you want to confirm the same thing, the next line of code where we can use the list function. So, to convert this sequence into a list type and see what is inside of it. So, you can see 0 1 2 3 4. So, you can see step value is 1 and we did not indicate the start value which defaults to 0, and so the argument that we had end was 5. So, it is indicating that we required 5 elements there. That would also be indicated by the end argument as well. So, 0 1 2 3 4. So, this is the collector, this is the iterator that we have just created. So, range function can be really useful in this sense to create the iterator for loop. Similarly, as take another example where we are giving all the argument, passing all the arguments. So, you can see the next line 0 start value, then 10 end value and then 1. So, if I run this, you can see 0 to 9. So, this is the list that we would like to iterate over. Now, the sequences that are typically produced using the range function, they have the start point. So, the start point would be included, but the end point is not included. So, same thing if you want if you want to understand more details about range function. So, I would also like to tell you in this help tab that we have in this Jupyter notebook interface. If I click this, and you can see there are many links for various help that we might require. So, if I just happen to because still we are into the Python built in functionality of Python. So, if I just click Python reference, and here in the quick search box I can type range, and I will get the details. So, whenever we are interested in finding out more detail about a particular function, we can always search. So, you can see range, and you can see in the parenthesis Python class built in types. So, if I just click here, so you can see all the details about this particular function. You can see range, start, stop, and step. So, you can see here start, you can see it clearly mentions here that it defaults to 0. So, this particular exercise related to finding help, related to finding Python reference, I am doing so that whenever you require more detail about a function which we have been discussing, and in coming lectures also will be talking about many functions, many built in types, many other things. So, you can always go to the appropriate reference and just type in that that particular word and find out the details. So, you can see start defaults to 0, and then we have the step thing, step argument, right. So, all these details are here, few examples are also given here. So, in this fashion you can see the step argument, you can see in this step argument, you can see if it is not specified then it will be 1 if the parameter was not supplied. The same thing I was mentioning here, you can see the start 0 if the parameter was not supplied. So, in this fashion we can always find out more detail about any function. So, as we said that step value could be negative also. So, in this example I am giving the start value as 4, the end value is -4, and the step is -1. So, if I run this is the iterator that we get. So, you can see here the start point 4 is included, but if you see the end point -4 it is not included. So, that is another point to note. So, whenever you are indicating your endpoint, so a value less than or greater than depending on the step value would be part of the collector, would be part of the iterator. Now, another usefulness of range could be that a rather typical usefulness, typically range is used as an index for iterating through sequences. So, now in this case something similar example we had used before. So, in this example you can see I am initializing a sequence here. This is a list of 1 2 3 4 5 elements, and then we have a for loop here. So, for x in range and length sequence. So, here you can see that we have first captured the length of the sequence. So, it has 5 elements. So, in a sense we are just passing on just one argument here. So, it is actually range 5 in effect, and the x will iterate over this range 5. So, when we say range 5, essentially we have created an iterator, created a collector iterator, and the x value will iterate over it, and our variable v5 is going to be assigned those values in each of the iterations of the for loop. So, if I run this, you can see the value of v5 variable comes out to be 5. So, because the last value in the sequence, you can see I am passing on x as an index within the for loop first line of code, sequence in brackets x. So, in a sense I am using the range, the iterator that I have created, that I am using as an index, so that any other sequence I can use that index and work on that particular sequence for whatever computations, whatever assignment and other things, manipulation I might require. So, in this fashion typically range is used as an index. Now, there might be certain situations where we might be dealing with large number of iterations. So, if we do not use range function, then will end up creating some sort of list or sequence, and that would require memory especially if that a large number of iterations are required. But instead if we use the range function, then memory use would be optimized. So for this we have given one example here. So we have initialized this variable sum at 0, and then we have a for loop here. So this is for x in range, and you can see 1 lakh. So 1 lakh iteration that we have in this piece of code, and then you can see we are using modulo operator here. So we have the conditional expression f x percentage 2 equal to 0 or x percentage 3 equal to 0, then all those values they are going to be summed up. So if I run this, so in this last large number of iterations, and you can see very higher value for sum, and if I run the value of x, you can see. So those many 99,999 that is the value of x. So whenever we are dealing with this situation, memory use can also be optimized using range function. Let us move on to the next thing, that is ternary expression. So ternary expression is especially useful whenever we are looking for a single line or expression in place of a value producing if else block. So we might have depending on, typically we use if else block whenever we would like to control the flow of execution, whenever we have some conditional expression which we would like to evaluate, which we would like to check, and then execute the following block, then execute the following lines of code. However, in some situation our if else blocks might be producing certain value, and some situation we might we would like to assign those value to some other variable, record that value in some other variable. So just to condense the code, we would like to use a single line or expression, especially in value producing, if we have a value producing if else block. So this ternary expression can be really useful in those situations. So let us take an example. So here how typically we would write if x less than 0 negative action. So in a sense this is a value of a string type, and else positive actions. If I run this, so to take an example, if in this case x value is greater than 0, so if x less than 0, then negative action won't be executed, the else block is going to be executed, that is positive action. The same thing, because here we are in a sense value of a string type is being produced, the same thing can be written in a ternary expression format, where we are writing like this. So negative action if x less than 0. So again if x less than 0, so I can write in this fashion, else positive action. So sometimes I would like to record this value. So this whole ternary expression can be assigned to some variable. So we can say like v7 equal to, and this ternary expression. So whatever value is there, it will be recorded. So sometimes there are situations where ternary expression could be really useful. So this is the end of session on Python basics. So whatever the basics that we wanted to cover, so that we have been able to cover here. Now some of these things we have not gone into more detail. Now we will in the coming lectures, however in the coming lectures we will go into more detail about many aspects that we have covered in brief in this particular session. Now we will move on to our next session, which is on built-in capabilities in Python. So in this particular session we will like to focus on, so in coming lectures we will focus more on the built-in data structures first. So typically these tuples, list, dicts, and sets. So these are the built-in data structure that we have in Python. So let us start. So we will start with tuple. So what is a tuple? So this is a fixed length immutable sequence of Python objects. So we have talked about the mutable and immutable objects in Python in our one of the previous lectures. So this particular tuple, and there we talked about that tuple is an example of an immutable object. So certain situation would make tuple quite useful. So how this is created? So we use a comma separated sequence, and whenever we are giving a number of values whether integer, float, or any string or any other type in a comma separated form, that will actually define a define or initialize a tuple. So, look at the example. So, first tuple that we are creating here top, and you can see 1 comma 5 comma 9. So, if I run this, I will have my tuple created here. You can see if I run top, I will get 159. So, this is the tuple. So, within the parentheses I will have all 3 elements. Similarly, so this is one way. So, there when we created this first variable top, we did not use any parenthesis, but in the semantics of tuple, whenever you are trying to print a tuple then it will be always with the parenthesis. We can all the time we can use parenthesis also in the creation of tuple itself. So, the next example is about this top 1, you can see I am using parenthesis and then 2 comma 6 comma 10. So, if I run this, we get 2 6 10. Now, we can have nested tuples also. So, tuple of tuples. So, we have another example here n top. So, in this case we have 159 as a one tuple, then comma and then second tuple within parenthesis 2 6 10. So, this would be our nested tuple. So, if I run this, you can see within the parenthesis we have 2 tuples as an element of the final tuple. Now, conversion of other Python objects to tuples. So, just like we talked about the basic types, the float, int and bool and those types. So, we had those functions to convert any other type to that particular type. Here also we have the tuple function. So, in this example if you can see here, I am passing on a list here. So, the element of list are 1 0 minus 1. So, if I pass on this list to this tuple function, I will get this particular list converted into a tuple type. So, if I run this, you can see the list 1 0 minus 1 which was passed on using the brackets now as converted into a tuple and it is displayed in parentheses. Similarly, I can tuple can also be used to create tuple function can also be used to create a tuple from a string. So, in the next example if I pass tuple om car and if I pass this as an argument, if I run this. So, you can see in the output I will have a tuple created of the characters which are part of this string. If I run this, you can see all the characters O then M then space then O then M K A R. So, in this fashion this tuple has been created. So, from a string also we are able to create a tuple. Now, if we are interested in accessing and working with the individual elements of a tuple. So, let us talk about that. So, accessing tuple elements. So, for this just like we have been doing before also in the previous lectures we have been typically using list and we have been accessing those list elements also using the using the brackets operator. So, here also for accessing tuple elements we use the same operator brackets operator. So, here as you might have understood by now that most of the sequences including list which we have used in the previous lecture, they are 0 indexed. So, whenever we are trying to access a list the indexing starts from 0. So, if the list has 5 elements, the indexing will start from 0 1 2 3 4. So, the 4 index will actually cover the 5th element. So, here top 4 if I want to access the 6th element I will give index as 5 because it is 0 index. So, if I run this, you can see I got the value k here for 6th element of top 4. So, I have given the index as 5 for 6th element. If you just count in the previous output you can see O then M then space 3 and then another 6th character is k. Now, we talked about that tuples are immutable objects, immutable Python objects. So, can they be modified? So, let us first create a tuple. So, we are passing on a list and we will have this top 5. So, this is the tuple that we have. First element is a string om, then we have a list as a second element, then we have a bool as the third element. So, if I want to change top 5 and a second element that is bool type, if I want to change it from false to true, if I run this I will get an error, you can see here. So, something similar kind of exercise we have done in the previous lecture also. where we were discussing mutable and immutable objects. So, here again just to display again that tuple is an immutable object. So, you can see we are getting a type error, that means tuple object does not support item assignment. So, any element that is part of the tuple we cannot directly change it. So, the value false that we had as the third element indexed as indexed with the value 2. So, that we cannot change. Then how do we modify, is any kind of modification possible? Immutable objects of immutable type like tuple. So, tuple might have tuple will have a number of elements. Now, some of those elements might be of mutable type. So, some of those elements can be, because of them being mutable type, they can be modified in place. So, we can in place in the sense we can use methods, and if the that element is mutable, then we can modify. So, in this case you can see tup5 1. So, that is second element in the tup5 tuple that we have, and then dot append. So, we are calling this append function, because the second element is actually a list. So, we would like to add another element in that list, which is a list of a tuple tup5. So, if I run this, you can see the whole tuple, and you can see the second element 0 1. So, earlier it was 0 1, now it is having 0 1 and 2. So, in this fashion if we have a mutable element we can modify. Now, let us move on to the next aspect, concatenation. So, can we concatenate two tuples? So, yes, that is possible. So, we can use plus operator. So, let us use this example tup5 plus tup4. If I run this, you can see I got a long tuple here, where tup5 and tup4, all the elements of tup5 and tup4 have been concatenated. So, they are coming one after another. So, you can see all the elements of tup5 they are coming first, and it is followed by all the elements of tup4. So, in this fashion we can concatenate two strings, two tuples. Now, there is another concatenation that we can perform, which actually involves repetition of certain elements. So, for example, if we have this tuple 3 that we had seen earlier, and if I just multiply it with 3, then all the elements that are there in tup3 they are going to be repeated thrice. So, let us run this and find out what is happening. So, you can see in the tup3 we had 1 0 minus 1, and this is another kind of repetition or concatenation we can do. You can see then we have another tuple concatenated to it 1 0 minus 1, then 1 0 minus 1. So, in this fashion we can concatenate. Now, let us move to the next aspect of tuple, unpacking tuple. So, in this case you can see on the next line, that is on the left hand side of the assignment operator we have a b c, which is a comma b comma c, which is another tuple, and on the right hand side we have the tup1. So, tup1 has certain values. So, in a sense when we are using assignment operator, the in a sense unpacking is happening, where the individual elements of the tuple are going to be assigned to the individual elements of the tuple which is on the right hand side. So, the values which are on the right hand side, element values which are on the right hand side tuple, are going to be assigned to the elements that are on the left hand side tuple. So, if I run this, so this unpacking will happen, and if I just want to access the one element, let us say C, you can see the value 10 is there. Similarly, nested tuple also we can do the same thing. So, here another example x y z p q r, and n tup we had earlier created. So, if I run this and if I look at the value of q here, I run this, you can see 6. So, even the nested tuple also this unpacking works quite well. So, this can help us in certain scenario where we can easily go, if we want to assign certain values, we can easily go through that. Now, there are certain other situation where tuples can be really useful. For example, swapping variable names. So, here typically if you have to swap variable names, you will have to write 3 lines of code, as we typically do in programming language, right. So x is equal to y, and then next statement y is equal to z, and then z is equal to. So in that fashion we will have to write our code and do swapping of variable names. However, with the help of tuple, this can be done through just one statement, you can see. So we have this, if you focus on the right hand side tuple. So we have these three elements a, b, c. If I want to change c with a variable name, then you can see on the left hand side I have changed the tuple CBA. Now the A will become C, and C will become A. If I just run this, and if I want to find out the value of C, you can see it has changed. So earlier it was 10, now it is 2, which was actually the value of A element. So this is about tuples. So at this point we would like to stop here, and we would continue our discussion on tuple in the next lecture. Thank you.